Good morning, student. In last lecture, we already discussed the atomic mass and atomic mass unit. In today's lecture, we will discuss the nuclear angular momentum. Right? Nuclear angular momentum, like electrons, both the protons and neutrons have an intrinsic spin. That means both proton and neutron are intrinsic spin. The spin of each nucleon is S is equal to half. Spin is denoted by letter S and spin of each nucleon is S is equal to half. The spin angular momentum is given by the spin angular momentum is given by under root S into S plus 1 into H cross is equal to, that substitute the value S is equal to half, that means half into half plus 1 into H cut is equal to, after solving this, under root 3 by 2 H cross, right? Since here H cross is equal to H by 2. Okay, must remember this. Then spin magnetic quantum number of the nucleon is this is the spin angular momentum is given by, right? Then spin magnetic quantum number of the nucleon is ms is equal to plus or minus half, right? In addition to the angular momentum, each nucleon has an orbital angular momentum denoted by letter L bar, with magnitude given by under root L into L plus 1 into H cross, where L is the orbital quantum number and have value L is equal to 0, 1, 2, 3 and so on, right? Then individual value of L are commonly designated by the following letter symbol. Here L is equal to 0, that time symbol L is equal to 0, that time S. L is equal to 1, that time P. Yes, L is equal to 2, that time D. L is equal to 3, that time F. L is equal to 4, that time G. L is equal to 5, that time H, and so on. Okay, must remember this. The total angular momentum of a nucleon is given by, this is the, must remember here, angular momentum, spin angular momentum, yes. Spin magnetic quantum number, this L, orbital quantum number denoted by letter S, spin angular momentum denoted by S, orbital quantum number denoted by letter L, and total angular momentum total angular momentum denoted by letter Z. Okay, then total angular momentum of nucleon is equal to under root j into j plus 1 into h cross. Okay, j is called as the total angular momentum, uh, total angular quantum number, and it takes value from याची जी व्हॅल्यू आहे ती कुठून घेतो आपण प्लस मॅग्निट्यूड ऑफ एल प्लस एस टू मॅग्निट्यूड ऑफ एल मायनस एस. टोटल अँग्युलर मोमेंटम of nucleon is equal to under root j into j plus 1 into h cut. Okay, here the value from j ची जी व्हॅल्यू आहे ती कुठून कुठपर्यंत घेतो. the value of j take place from magnitude of l plus s to magnitude of l minus s. Okay, that means in here we discuss there are three types. First one is the spin angular momentum, momentum denoted by letter s is equal to under root s into s plus 1 into h cut. Second one, the orbital angular momentum is equal to denoted by letter small l and is equal to under root l into l plus 1 into h cross. And third one, total angular momentum denoted by letter small j and is equal to under root j into j plus 1 into h cut. Okay, here the value of s in spin angular momentum, the value of s is equal to plus half to minus half, right? Here value of orbital angular momentum l is equal to 0, 1, 2, 3 and so on. And here denote value of l is equal to 0 is s, value of 1 is denoted by p, s, p, d, okay, and so on. And in here value of j is equal to magnitude of l plus s to magnitude of l minus s. Okay, must remember these three types of angular momentum. Nuclear angular momentum has three types. One is the spin angular momentum, second one is the orbital angular momentum, and third one is the total angular momentum. Okay, then we discuss the types of coupling system. Okay, next point is the coupling. There are three types of coupling. First one is the Alias coupling, second one is the SS coupling, third one is the JJ coupling, right? These three types here we discuss. These are the coupling types. Then first of all we discuss the Alias coupling. Right? In this coupling scheme, it is assumed that there is a weak interaction between the orbital L and spin angular momentum vector of the individual nucleon. Weak interaction between orbital L and spin angular momentum. ओके, या दोघांमध्ये वीक इंटरॅक्शन आहे एल आणि एस मध्ये, राईट. देन instead the orbital angular momentum vector of all nucleons assumed to be coupled to gives rise the resultant angular momentum it given by, that means resultant angular momentum L bar is equal to L1 bar plus L2 bar plus L3 bar and so on. This is the resultant angular momentum. Okay, similarly in spin angular momentum vector of all nucleons are coupled to gives rise to a total spin angular momentum and is given by, this is the spin angular moment, total spin angular momentum is equal to S bar is equal to S1 bar plus S2 bar plus S3 bar and so on, right. The total angular momentum of nucleus arises from the intrinsic spin of angular momentum of its proton and neutron and from the orbital angular momentum due to motion of these nucleons within the nucleus, and it is given by, that means total angular momentum denoted by letter here I is equal to L bar plus S bar. Okay, then and its value generally is denoted by letter J, but here we take the value letter I, and its value I takes the value from plus L plus S to the magnitude of plus L minus S, right. The magnitude of the total angular momentum I is given by, magnitude of the total angular momentum is given by I into small I into I plus 1 into H cut, where I is called as the nuclear spin. Nuclear spin. Okay. If the nuclear spin I is equal to, if I is equal to, this I is equal to 0, 1, 2, 3 and so on, for and so on, it is called as the boson, right. And if the nuclear spin, if I is equal to, if I is equal to, value of I is equal to half, 3 by 2, 5 by 2 and so on, then it is called as the fermions. Fermions, right. If value of I is equal to 0, 1, 2, 3, then these are called as the bosons particle, and if I is equal to half, 3 by 2, that means I is equal to 1 by 2, 3 by 2, 5 by 2 and so on, then these are called as the fermions. Must remember, this is very important point. Then the nomenclature of the nuclear levels in Alias coupling, then they follow the usual nomenclature of the atomic spectroscopy. For capital L is equal to, capital L is equal to 0, 1, 2, 3 and so on. The level are designed as, we know L is equal to 0 means yes, L is equal to 1 means P, L is equal to means D and so on. Okay, then the quantity 2s plus 1 is called as the multiplicity. This is very important. 2s plus 1, this is the formula of the multiplicity, called as multiplicity. Multiplicity, must remember this. 2s plus 1 is called as the multiplicity, and it is written as a superscript before the letter design the L value. That means the spectroscopic term is written as 2s plus 1 into x into j, right. This is the notation of the spectroscopic term. Okay, x is the notation of the level corresponding to the value of L value. Okay, must remember this. we briefly discuss this. Here we discuss some examples. This is notation 2s plus 1 x, and here z, right? Okay. Here we discuss some examples. If L is equal to 0 and S is equal to, here we take not I, here we take the J, then S is equal to 0, that time we know J is equal to L plus S, that means 0. Okay, the spectroscopic term is 2s plus 1 into here x means L is equal to 0 means S, J's value 0, that means 2s plus 1, 2 into 2s plus 1, 2s is equal to 0, that means 0, that means 1s 0. This is the spectroscopic term. Another one example, if L is equal to 0, S is equal to 1, then the J is equal to, what is the value of J? L plus S means 1. Then spectroscopic terms 2s plus 1, S, L is equal to 0 means yes, and value of J is equal to, then 2s plus 1, S is equal to 1, that means 2s plus 1, 2 into 1, 2 into 1, 2 plus 1, that means 3, yes, 1. This is the spectroscopic term. Another one example here we discuss, if L is equal to 1, S is equal to 0, that time J is equal to 1, and spectroscopic terms 2s plus 1 into S, here J is equal to 1, S is equal to, L is equal to 1 means P, right? P, and here 1, right? Then another one example here, if L is equal to 1, S is equal to 1, that time J is equal to magnitude of L plus S to magnitude of L minus S, that means 2 to 0, that means value of J is equal to 2, 1 and 0, right? Then not 2 to 0, that means 2 and 0 are the value of J. J is equal to 2 and 1, okay, 2, 1 and 0, right? Then spectroscopic term 2s plus 1, that means 3, L is equal to 1, P2, 3P1, 3P0 and so on. These are the spectroscopic terms, and here we discuss some examples also. Okay. Next one is the JJ coupling. In this coupling, it is assumed that the coupling between orbital angular momentum vector L bar and spin angular momentum vector S bar, right? It is predominant for the same nucleon. These combine to form resultant angular momentum J bar, right? And is given by J bar is equal to L bar plus S bar, where the value of J bar is takes from plus L plus S to magnitude of L minus S. Okay, the resultant nuclear angular momentum J bar is equal to J1 bar plus J2 bar plus J3 bar and so on, right? Then the magnitude of the total angular momentum is given by J is equal to under root J into J plus 1 into H bar. It is also called as h cut or h bar. Okay, h cut. The total angular momentum j bar can be oriented in a space with respect to a given axis, okay, to j plus 1 direction. The component of any other orientation along the axis is mh cut, where m is the value of I to I plus j to minus j. Okay, that means in today's lecture we discuss the different types of coupling system. Here first of all we discuss the Alias coupling. In nuclear angular momentum, in today's lecture we discuss the angular momentum, that means spin angular momentum, orbital angular momentum and total angular momentum. Spin angular momentum denoted by letter S, right? Spin angular momentum denoted by letter S, orbital angular momentum denoted by letter L, and total angular momentum denoted by letter Z. And then we discuss the coupling system. In coupling system, that total spin angular momentum is equal to under root S into S plus 1 into h cut. Then orbital angular momentum L bar is equal to under root L into L plus 1 into h cut, and total angular momentum j bar is equal to under root j into j plus 1 and into h cut and so on. ओके, म्हणजे आजच्या लेक्चरमध्ये आपण अँग्युलर मोमेंटम जे आहे, स्पिन अँग्युलर मोमेंटम, ऑर्बिटल अँग्युलर मोमेंटम आणि टोटल अँग्युलर मोमेंटम हे डिस्कस केलं. आणि कपलिंग सिस्टीम जे आहे, एलएस कपलिंग, एस कपलिंग, जे कपलिंग, त्या कपलिंग सिस्टीम पण आपण डिस्कस केल्या. ओके, स्टॉप हिअर. थँक्यू व्हेरी मच.